Okay, the first thing I'm going to take a look at is on a problem like example 4, is that reduced? So I'm going to factor that. So I'm going to say k of x, that equals to x, what? X minus 2 and x minus 5 all over x minus 3. So that can't be reduced. So my vertical asymptote is when my denominator is 0. So when x equals 3. Get rid of that equal sign there. It should be a colon. So I've got a vertical asymptote at x equals 3. So I'm going to go over here at 3. I'm going to draw a vertical asymptote going through my points, my line. Okay, now, here's one. We don't have a horizontal asymptote because notice the degree is greater. The degree of my numerator is greater than the degree of my denominator. If that's the happen, you want to use long division. Actually, I put this on the wrong page. So to find your slant asymptote, this is what we're talking about on this page. So what happens, I use my long division, and I divide them out. And what happens, my remainder, as x gets really, really big, notice my remainder goes to 0. So I really don't care too much about the remainder when I do this. So now, let's take x squared minus 7x plus 10. Let's divide it by x minus 3. I'm going to use synthetic division for that. So I'm going to go 3. Then I have 1x squared negative 7x plus 10. So if I bring down my 1, I get 3, so I get negative 4. Negative 12, I get minus 2. So my slant asymptote is going to be x minus 4 minus 2 all over x plus 3. But like I said, this 2 over x plus 3, as x gets really, really big, that goes to 0. So I'm going to graph x minus 4 as my slant asymptote. So I go down 1, 2, 3, 4. And then I notice my slope is 1. So here is my slant asymptote. Now, can we find our x or y intercepts? My y-intercept occurs when x is 0. So let's put in 0 for x. So I got 0 minus 0, which is 10, all over negative 3. So that's negative 3 1/3 then, isn't it? So I'm going to go down 1, 2, 3. 1, 2, 3 1/3. Now my y-intercept, or keep on saying that, my x-intercept occurs when f of x is 0, or k of x is 0. In other words, I'm going to kind of run out of room here. I'm going to say 0 equals x minus 5 times x minus 2 all over x minus 3. So in other words, if I multiply both sides of x minus 3, we have x minus 5 times x minus 2 equals 0. So I know my x-intercepts occur at 5 and 2. So I'll plot those. Two, 3, 4, 5. Now I can see by the way if I place my y-intercept and my x-intercept, my graph is going to look something like that. Now, you also can make a table, and you want to pick numbers on either side of your x-intercept of your vertical asymptote, which is at x equals 3. So what I'm going to do is I'm going to pick a point for 4, pick a point for 2. Okay, now, you can do this in a couple different ways. I'm going to put in 4 here. So 4 squared is 16, minus 4 times 7 is 28. So if I go 16 minus 28, and then I add 10, I'm going to get negative 2. And then I go all over 4 minus 3 would be 1. So I'm at 4 and negative 2. And that kind of tells me, oh, look at that. That point's pretty much where I guessed it was going to be. And then I could do the same thing for 2. 2 squared is 4. Minus 7 times 4 is 14. So if I go 4 minus 14 plus 10, oh, that's my x-intercept, which is 0. Now, of course, don't trust me. Graph it yourself to see how it checks out. So now we're going to graph this ourselves. Let me go back here. So here's my graph. In order to see I'm going to plot my oblique asymptote so you can see that. And here's my vertical asymptote. And we've got that one. And that works out pretty darn nifty.